What? Oh, what? Tablet? I don't.
So we're starting 14-1. Homework's due Wednesday. It might change to Thursday, but I'm planning on Wednesday. And yeah, 2 more minutes and then Stefan, you ready to come up? All right. We're going to use the unit circle a lot today, so if you want to grab that out, that'd be good too. Or a calculator, either one. 14-1, that's what we're going to have the homework on. I haven't put this up yet, but just wanted to let you know it's due Wednesday. Start on the math to do. Don't need any calculators on these ones. If you do calculations in your calculator, they're going to be incorrect because they're not going to be accurate. They're going to be rounded unless you know how to switch. All right, so Stefan's going to help you out today. You can thank him later. There's a stylus if you want to use it. And it's all yours. Oh, it's right underneath the iPad.
So since this is a 30, 60, 90 triangle, you could use that, I guess. And so, first you have to solve this side, and if you use this 30, 60, 90 triangle rule, this would be 7 square root 3 over 3. And then to find x, it's just times 2. So you times this by 2, and then it's equal to 14 square root 3 over 3.
So what, remind us again, what value does this represent in terms of A?
2a.
2A, write that down just so it's clear. So what he did was he recognized this is equal to A root 3, solve for A. I need 2A times it by 2. Boom, he's got it. Nice job.
For this one, I do a triangle. And then I use the top angle, and if the sine of z would be opposite over hypotenuse, so 2 and 5, and the cosine would be adjacent, which is square root 21, and the tangent is the opposite over adjacent, so it would be
Double check that 5 though. Is that 5 correct? Yep, looks good. And if you wanted to, you could rationalize it, and it'd be 2 root 21 over 21, right? So if I ask you to rationalize it, you do that. Round of applause. Thanks, Stefan. Nice job. Great. Well, now you have your wonderful little flippy books, and now we can do some problems. We're going to graph and really focus on accurately graphing sine and cosine. And today we're only going to get through a couple topics. The first one is amplitude. So if you flip to that first page, we're talking about amplitude. This is the general form for a sine function. General form. If I play around with a values, I'll scale it. It'll be either taller or shorter, right? Or maybe it'll reflect over the x-axis. If I play around with c, it will shift it left or right, correct? If I play around with d, it'll shift it up or down. If I play around with b, it will shrink or stretch it horizontally. So just an idea for what those numbers do, what those variables do. Amplitude. If I give you this, it's really easy to tell me the amplitude. You just look at A and take the absolute value. But if I give you a graph, it's 1/2 the height of the graph. Well, if you take a look at what the height of the graph is, I'm saying this. That's the height. Take 1/2 of it, and I'm telling you how tall any one hump is, right? I'm telling you how tall any one hump is. So for this one, how tall is one hump?
3. I can't see all
4. 4. How tall is this hump? Look on your paper. It's easier to see. Nope. Where are you getting 2 from?
Oh, the other one.
The hump is at 1. One hump is 1. The amplitude or the height of any hump is 1. The height of the graph is 2. That's correct. But the amplitude is 1. Amplitude is 1/2 the height of the graph. Now this example isn't on here, but what if I just gave you data points? What if I just gave you data points? How would I find this? Well, here's how. You should probably write this down, Aiden. So if you take the max value plus the minimum value, and I divide it by 2, let's see what that would give me. So max value plus minimum value divided by 2, well, you will get the amplitude. We want to be careful to make sure that we're talking about absolute value of these numbers. So for example, absolute value of this, 4, absolute value of this, or add them together, you get 8 divided by 2, and you get 4. And that's the height of any one hump. Does that make sense? All right. So that's how you can do that. Let's see. I suppose that would actually be. Did I get that wrong? Top minus bottom divided by 2. It must be top minus bottom. It must be top minus bottom because 4 minus negative 4 gives me 8 divided by 2, and you get 4. Okay, so my apologies. All right. Yes,
What is that?
that would work too.
Okay.
That would work too. Say it again.
Like, you wrote A equals what is the first one? Max. Okay.
Max minus min divided by 2. Or again, with the absolute value, that will work as well. All right. Well, if you look back at these graphs, there's two things that letter A can do. It can stretch or compress it vertically, or, like we said, it can reflect it. It can reflect it. What axis will it reflect it over? The x-axis. So, for example, this one has been reflected by, over the x-axis, and it's also been stretched by 2. Okay? Well, let's practice saying what the amplitude is and then also graphing. I'm going to start with graphing because that's the thing we probably all need the most help with. If you don't focus on this one, you're going to miss some of the subtleties, and I guarantee you it'll be wrong when I grade it. So, first thing you want to do is graph the parent function. What's the parent function? You got it. We don't want general form, we just want the most basic, which is sine of x. I'm going to graph it in a different color because that's very helpful. Now let's go through certain values that we know from the unit circle. If you look at my hand right here, if I go negative 2 pi, negative 2 pi, negative 2 pi, sine of that is what value? Sine is y or x?
Y.
Okay, how tall is my y when I go 2 pi?
0.
0. So what's sine of negative 2 pi?
0.
So plot a 0. How about negative 3 pi over 2? Let's take a look at the hand again. Negative 1 pi over 2, 2 pi over 2, 3 pi over 2. How tall am I? Negative 1 pi over 2, 2 pi over 2, 3 pi over 2. Sine of negative 3 pi over 2 gives me 1. Okay? So at negative 3 pi over 2, which looks to be about here, we should have 1. Sine of negative pi. Look at the hand again on the unit circle. Negative pi. Sine of that gives me what? Sine of this, just look at the hand. Pretend it's on the unit circle. Negative pi. Now I'm here. Sine of that gives me what? 0. Sine of negative pi gives me 0. So we're going to put 0. Sine of negative pi over 2. What do you think that is?
1.
It's not 1. It's negative 1. Negative 1. Sine of 0. What's that? 0. You got it. Sine of pi over 2. What's that? 1. Sine of pi. 3 pi over 2. Okay, are you seeing how we're doing this? 2 pi. We're using the unit circle to find out these values. Sine evaluated at pi is 0. Sine evaluated at 3 pi over 2 is negative 1. 2 pi, 0. You need to know these ones by now. These are basic. All right, this is the parent function. I plotted points because points are a lot easier to transform than functions, and then I can give myself a nice sketch. Now I'm going to do 3 sine of x in green. If y is equal to sine of x, what did I do to all my y's? Multiply them by 3. So what's going to happen with all those reference points? multiplied by 3. So that's what's beneficial when you plot these points. Is that one going to go anywhere?
No.
3 times 0 is still 0. Is that one going to go anywhere?
Yes.
Where's it going?
Up.
Up to 3, right? Is that one going anywhere? Nope. Is this one going anywhere?
Mhm.
Negative
3.
3. So I think you got it. Am I just plotting these points anywhere in terms of my x values? No. I'm making sure that they line up exactly where I had evaluated them before. Okay, those are reference points. And now, sketch. Do you think it's important that my graph looks like a curve? Smooth? Mhm. Okay. Straightforward? Okay. Why don't you try the next one with your partners at your table? Try that for 2 or 3 minutes. 2 things happened here. What's the first thing that happened? Flipped over the x, then scaled by. So instead of being 1 tall, it's going to be, and then it's going to be flip. Okay? Scale it, flip it. Scale it, flip it. That's what you do to all the points. Give that a try.
So how are you getting the points?
I'm evaluating sine for these x values. Sine of negative 2 pi, 1 pi, 2 pi. How tall am I on my unit circle? Because sine talks about y. I'm at unit circle, 1 pi, 2 pi. Now I'm back here. How tall am I? Oh, sine is the y value. That tells me how tall I am. So that means sine of negative 2 pi is 0. Negative 3 pi over 2. 1 pi over 2, 2 pi over 3 pi over 2. How tall am I? 1. Okay? So that's how I'm getting those points. Okay?
Yeah, so first you plot the parent function. Plot at the top first. Like the little function. And then
Yeah,
you
it's like,
plot
it
the
should
little
look like
function.
DNA. Like the one with the, yeah.
If you're confused about where we're getting these points, again, for all these special x values, I know special values from the unit circle that I want to plug in. Pi over 4, pi over 3, pi over 6, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. That's how I get these nice reference points, right? Okay. Now in green, I'll do this one. I'm going to shrink it by a half, then flip it. Shrink it by a half, then flip it. Shrink it by a half, then flip it. Shrink it by a half, so it's at 1/2. Flip it, now it's at negative 1/2. You got it. Are the zeros changing? Nope, so those are fine. Shrink this one by a half, it's at 1/2. Flip it, now it's at negative 1/2. Shrink it by a half, now it's at negative 1/2. Flip it, now it's at positive 1/2. Negative 1/2. Positive 1/2. And I draw a nice little sketch. Does that look about like what you got? Okay. So again, you need to pay attention to the operations that are happening. Shrink it by a half, flip it. Shrink it by a half, flip it. That's what's happening to all the y values. Okay. I took care of graphing first because that's the hard part. What's the amplitude of my green graph for the first one? What's the amplitude for the green one? 3. I look right here. The height of any one hump is equal to 3. What about for this one? It's equal to 1/2. You got it. It's not negative 1/2 because we take the absolute value. You got it. While I'm trying to get this back up, maybe you can ask your classmates next to you if you're having trouble. Ten more minutes. Okay, vertical shift. That's a pretty simple one. Vertical shift. Only one of two things happens. Shifts up or it shifts down. Can't happen both ways. Up or down. What letter we already talked about refers to a vertical shift? D. This tells me my vertical shift. Well, all this is telling you, these are just worked examples. Guess what? This one shifted up 3. This one shifted from here to here, down 4. Pretty easy to see, right? Okay. So we see that. Now let's try it ourselves. Graph the parent function, sine of x. It's already there for you. Shift it down 2. That's all you have to do. Find reference points you're going to use, not on your cell phone, but maybe on the paper, and then shift them down. 2. I'm going to start by doing this. Graph where my x-axis is now going to be. Where's my x-axis now going to be? -2, right? I shifted it down 2. Well, that one's going to be here. That one's going to be here. That one's going to be here. 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 It's at 1, it's going down 2, so now it's at -1. It's at -1, it's going down 2, now it's at -3. It's at 1, it's going down 2, now it's at -1. Okay, does it look like a vertical shift happened? Yeah, looks like it was shifted down 2. Let's just verify that I gave you the right formula. If I wanted to find the amplitude here, give me the max y value. -1. Subtract. Let's just -1. Subtract. What's the minimum? -3. -1 plus 3 gives me 2. 2 divided by 2. I get an amplitude of 1. Is that my amplitude? Yes. Okay. Would it have worked the other way? Absolute value is 1. Absolute value of -3 is 3. Add them together, you get 4 divided by 2. Yep. So, oops, made a mistake on that one. Difference of max and minimum divided by 2. Okay. All right, so I'll fix that one for period 1 and 5. And let's do this one. 2 operations, what were they that happened? Reflection, over, and there you go. I would do this in 2 steps. First, either shift, no actually I would do this first. Reflect it, then shift it up. I would do reflect it, then shift it up, personally. Or just do a table. It's up to you. But I'm going to do reflect, then shift. Here's my reflection. Shift up 3. Keep track of where your x-axis is going to be. It's at 0. I go up 3. Now it's at. There you go. That makes plotting these baseline points very easy. Now I just put them along this line. Up 3. Up 3. Up 3. Oh, I already did the reflection. So I'm now doing, oh, was I doing the purple? Yep, I was doing the wrong one. Thanks, Rig. Let's do the baseline ones first. From here, all of them are going to be at 3. Okay. Shift this guy up 3. Now it's at 2. Shift this top guy up 3. Now he's at 4. Does that look right? Yeah. If you're confused on any step so far, what's confusing you? Everybody's 100%? You all got it? Okay, great. Then the last thing I want to do today is period. All right, I have to talk about period and cycle. Subtle difference, and you should pay attention because anytime there's subtleties, there's lots of room for errors. Period of a trig function is the length of one full cycle. So the length is a number. The length represents, the number represents the length of one full cycle. Well, a cycle is observable. Describe for me what a cycle is. If this is a cycle, this is a cycle, this is a cycle, this is a cycle. Describe for me in words what a cycle is. You just have to look at the paper and tell me what you see. This is a period, this is a period, this is a period. How do you know when when a cycle begins and ends? All right, just put it into words.
When it repeats?
When it repeats. Very good. Look right here. I start going up on my roller coaster. Come back down. Am I about to start my roller coaster again? Okay. So you look for when the repetition starts and when it ends, right? Starts here, ends here. That's one period. The period is 2 pi. That's the length of one full cycle. Therefore, the period is 2 pi. Okay. Cycle is observable. Period is measurable. Period measures the cycle. Okay, well, let's figure out how to find the period. It's a real quick formula. It's right here for you. Take 2 pi and divide it by the absolute value of b. Take 2 pi and divide it by the absolute value of b, and you will get your period. All right? So let's do that. 3 sine of 1/2 x. Find the period. Well, what's the period? 2 pi divided by absolute value of 1/2. I don't need the absolute value. 2 pi divided by 1/2. 2 divided by 1/2 gives me 4. So this is equal to 4 pi. What's the period?
4 pi.
All right, here we go. 4 pi. We stretched 3 sine of x so that one cycle is completed in 4 pi. It starts its ride, it goes down, it comes back up every 4 pi. Okay, and we only have 4 more minutes left, but I want to make sure we do this before you leave. Okay, sine of x is here. 3 sine of x. What do I do to all the y values? Multiply them by 3, right? So maybe I want to graph that one, maybe not. It'd be messy, so I'm not going to do that. I'm going to do a table. I'm going to do a table, x, sine of 3x. And then what do you think 3 sine of x. 3 sine of x. And then what do you think I'm going to also do in this next column? 3 sine of 1 half x. This is the one that I want to graph. Right? This is the one I want to graph. X. What are some good values we should plug into sine that we know? We can evaluate sine at. Give me some ones that we know. Okay, we know 2 pi's, we know negative 2 pi's, we know pi, we know pi over 2, 2 pi over 3. Those are what you want to substitute for x, right? Yes. Well, let's do that. X is equal to 0. What does 3 sine of x give you? 0. Well, what does 3 times sine of 1 half of 0 give you? 0. So for x is equal to 0, 3 sine of 1 half of x is just 0. 1 half of 0 gives me 0. Sine of 0 gives me 0. 3 times 0 gives me 0. Just something you plug in on your calculator or use unit circle. How about another one that I know? Pi over 2? Yeah, I'm going to skip that because pi over 4, sine of pi over 4 is square root 2 over 2, times 3 is 3 square root 2 over 2, and that's kind of hard to graph, right? Let's graph another one. How about pi? If I substitute in pi here, I'm going to be taking sine of what? If I substitute x is equal to pi, what am I evaluating? Sine of half pi or pi over 2. Do I know what sine of pi over 2 is? What is it? Sine of 90 degrees. What's the y value? 1. What's 3 times 1? 3. So when I substitute in pi, I get out 3 times 1, so I get out 3. So I'm going to go over to pi, and I'm going to go up to 3 and plot a point. I got to the top of my roller coaster. Now I need to get back down to the bottom again. Plug in 2 pi. 1 half of 2 pi gives me what? 1 half of 2 pi gives me what? 1 half of 2? You get pi. What's sine of pi? 0. So what do I get for my output when I plug in 2 pi? 0. So I go to 2 pi and I plug in a 0. Do I start to see now what it's going to look like? Where's the next, before you leave, because I know the bell's going to ring, where's the next big hump going to happen?
3 pi.
3 pi, you got it? Where's the next 0 going to happen?
4 pi.
4 pi. Do you see how you can do this using a table? Sketch it. And there you go. Did it complete 1 full cycle in 4 pi?
Yeah.
Yep. And we're good. So that's what I wanted to cover today.